Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Multiplying and Dividing with Scientific Notation. You can follow along with me as I read this from the top in the box. It says to multiply or divide numbers that are in scientific notation, we can use previously learned rules for multiplication and division of monomials. So let's take a look at some examples. The directions say to evaluate each expression, which means find the value of the expression. And we are supposed to express the result in scientific notation. So here we have 2.8 times 10 to the 6th, and then since there is nothing between the two sets of parentheses, that means multiplication, and we have 3 times 10 to the 7th. Now, one of the rules we learned not too long ago is that when you multiply like bases, you can add their exponents. So, who are the like bases? Well, 2.8 and 3, they are not like bases, but 10 and 10, they are like bases. So what we can do is we can use the commutative property of multiplication, switch this around. So we have the 2.8 times the 3 next to each other, and then we have the times 10 to the 6th times 10 to the 7th. And what we can do, from what we learned earlier, whenever you multiply like bases, you can add the exponents of those like bases. So 10 to the 6th times 10 to the 7th would be 10 to the 13th. You add their exponents. Now, 2.8 times 3, you could do that off to the side, since you really shouldn't be using a calculator too much on these guided notes. So that's going to give you 8.4, and there's your final answer. And hey, this one is already in scientific notation because the first number, 8.4, is already a number between 1 and 10. So that is already in scientific notation, which is quite nice. Problem number 2, let's take a look at this one. Once again, we can use the commutative property of multiplication, switch the order, and we can then take the like bases, which are the tens, and since we're multiplying them, we can add their exponents. So negative 4 plus 12. Now, since this is a negative plus a positive, you would subtract in your head, and that would give you 10 to the 8th. And then you could go off to the side, do 5.44 times 6.2, and you would get 33.728. Now, here's the deal. That answer is not in scientific notation. Why? Because 33.728 is not a number between 1 and 10. Remember, scientific notation has to start with the factor being a number between 1 and 10, then taken times 10 to the power. Well, 33 is not between 1 and 10. So what we're going to have to do is take that 33.728 and let's make that 33.728, let's make that become 3.3728. Now, how do I do that? Well, that would be times 10 to the first, because the original number was 33. That was a number that was already larger than 10, so this is why it is going to be 3.3728 times 10 to a positive 1 power. Only numbers that are small, like 0 point something, those numbers would have negative exponents when you write them in scientific notation, but that was not the case here. Here we had 33.728, so this is 3.3728 times 10 to the first, and then once we do that, then we can take the 10 to the first times 10 to the 8th and get that to be 10 to the 9th. And now we have a final answer that is in scientific notation. So it's nice if most of our problems end up being like problem number 1, where 2.8 times 3 gives you a number that is already between 1 and 10, the 8.4. But most of the time that's not going to happen. I don't know about most of the time, but a lot of times that's not going to happen. So please keep in mind, when a problem like number 2 pops up, where after you multiply you get a number that is bigger than 10, then you're going to have to go a step further and put that into scientific notation. So that way the first part of it is a number between 1 and 10. All right, so problems 3, 4, and 5. Let's do number 3. No, you know what? Do I want you to do this one on your own? Yeah, I think you can do 3, 4, and 5 on your own. So hit pause on the video, do those 3 problems, 3, 4, and 5, and then hit play when you're ready to see how you did. All right, I hope you've already done numbers 3, 4, and 5. If not, you better hit pause now. So here we go. We're going to use the commutative property, And then 10 to the 17th times 10 to the negative third would be 10 to the 14th. And the nice thing about 3.2 times 2.5 is that would give you 8.00, which is really just the same as 8. And so that is already in scientific notation because the first part of it, the 8, is a number that is already between 1 and 10. So that's what we need for scientific notation. All right, problem number 4. Using the commutative property, we are going to switch things around. 10 to the negative second times 10 to the negative 7th would give us 10 to the negative 9th. 4.3 times 7.2 is 30.96. Now, is 30.96 in scientific notation? No, it is not. So what we have to do is make that become 3.096. And to do that, we then have to make that times 10 to the first power. Now, after we do that, we can take the 10 to the first times 10 to the negative 9th. Now, a positive plus a negative, you're going to subtract in your head. 1 plus negative 9 is negative 8. And so you're going to get 3.096 times 10 to the negative 8. And then finally, problem number 5. Again, same idea. Use the commutative property. 10 to the 9th and 10 to the 2nd is going to give you 10 to the 11th. 6.7 times 9.8. If you go off to the side and figure this out, it will be 65.66. Just like problem number 4, 65.66 is not a number between 1 and 10, so we're going to take that a step further and make that 6.566 times 10 to the first. And then 10 to the first times 10 to the 11th would be 10 to the 12th. And now we have an answer in scientific notation. Now, problem number 6 is already typed up for you on your guided notes. This one is a little bit different because the first part of it is already in your traditional scientific notation. But now we're multiplying it times a number that is not already in scientific notation. So there are 2 ways of doing this. Method 1, per se, is where you would take the 3,600 and write it in scientific notation. That is 3.6 times 10 to the third. So you could do that first, and then you could use the commutative property. 4.9 times 3.6 would give you 17.76. But, and 10 to the 5th times 10 to the 3rd is 10 to the 8th. But, as I was about to say, 17.64 is not in scientific notation. So that has to become 1.764 times 10 to the 1st, and then 10 to the 1st times 10 to the 8th gives you 10 to the 9th. And then finally, you have an answer in scientific notation. Now, I actually have found from experience that even though you would think that this would be the easier method, method 1, where you put them in scientific notation first and then multiply, I actually like what I call here method 2, where you actually don't put the 3,600 in scientific notation at all and just take it times 4.9. Now, I know that might seem like this would be the longer way of doing it, but if you notice, it's actually 1 step shorter by the way that I was showing my work here. So 4.9 times 3,600, you'd go off to the side, figure that out, and get 17,640. Now, obviously, that's not in scientific notation, but no big deal. We know we have to put the decimal point after the 1, so that way it's the number between 1 and 10. So how many digits do we have to account for that were after that 1? That's the 7, the 6, the 4, and the 0. That's a total of 4 digits. That's why this is 10 to the 4th when you write it as 1.764 times 10 to the 4th. Now, we're not done. We still have the 10 to the 5th. So 10 to the 4th times 10 to the 5th gives you 10 to the 9th, and that then is an answer in scientific notation. So you can technically use either method that you want, but I personally find method 2 to be a little bit quicker. All right, problem number 7. Hit pause on the video, try it on your own, and then hit play once you're ready to see how you did. All right, I hope you've already done number 7 on your own. I like method 2, so I'm going to take 2.56 times 740,000. Off to the side, I do that, and I get 1,894,400 times 10 to the negative second. Now, obviously, 1,894,400 is not in scientific notation. So I need to put the decimal point after the 1. So that means there are 1, 2, 3, 4, 5, 6 digits that I have to account for after that decimal point. So that's why it is times 10 to the 6th power. Now, 10 to the 6th times 10 to the negative second. You would add the exponents, but actually you're going to subtract in your head because it's a positive and a negative. So that's going to give you 1.8944 times 10 to the 4th power. You could have done this problem using method 1, as I called it back in number 6, where you made the 740,000 become 7.4 times 10 to the 5th power. And then you could take it from there. You should eventually get the same answer that I get. Might take an extra step, but it should end up being the exact same thing at the end. All right, on the second page of the guided notes, let's look at some examples with division. And obviously, as we've seen already in this unit, the most common way of showing division problems is a fraction bar. Now, this is a different exponent rule. When you divide like bases, you will subtract their exponents. So, the like bases here are the tens, just like we were talking about on the first page. We're going to subtract their exponents. Now, the way I like to do this, kind of like we were doing on the first page, is split it up into two different parts. Take the 9.02 divided by 2.2, and that would give you 4.1. Then 10 to the 18th divided by 10 to the 6th, that's going to give you 10 to the 12th because you would subtract their exponents, and that's how that works. Now, the nice thing about this answer is that 4.1 is already a number between 1 and 10, so once again, then that's already in scientific notation. Problem number 9 is also already typed up for you on your guided notes. Same idea as number 8. Split it up into two separate parts. Do the division off to the side. 10 to the 7th and 10 to the 2nd. Subtract their exponents. You get 10 to the 5th. Now, this time, 0.78. That is not in scientific notation. So, remember, whenever you have small numbers that are 0 point something, they are the kind of numbers that are going to get negative exponents when you write it in scientific notation, times 10 to a power. So this is going to become 7.8 times 10 to the negative first. And then, obviously, we still have the 10 to the 5th. 10 to the negative first times 10 to the 5th would be 10 to the 4th. And now we have an answer that is in scientific notation. All right, I'm not going to lie to you. If you use your calculator for the division pieces of this problem, that's probably not the end of the world. That would probably be okay. So with that in mind, numbers 10, 11, and 12, why don't you go ahead and try these three problems on your own. Hit pause on the video, do these three problems, then hit play when you're ready to see how you did. Okay, I hope you've already done numbers 10, 11, and 12. If not, you really should hit pause on the video now and try them on your own. So, splitting this up, 6.12 divided by 1.8. Again, I'm okay if you use your calculator for this. That's going to give you 3.4. 10 to the 4th times 10 to the 11th. Now, I hope you realize that the exponent on top would come first. So this is not 11 minus 4. I'll say that again. This is not 11 minus 4. This is 4 minus 11. You're like, does that matter? Yes, it does matter, because 11 minus 4 would be 7, but that would be wrong. This is 4 minus 11, which is negative 7. So please make sure that you always start with the number for the exponent that's in the numerator up on top. That must be first, then subtracted by the exponent that was on bottom. So anyway, this one is already in scientific notation because 3.4 is a number that is between 1 and 10. Problem number 11. When you do 2.198 divided by 3.14, that is going to give you 0.7. Now, 10 to the 2nd divided by 10 to the negative 3rd. You're going to subtract their exponents, but this is a little bit more interesting. Now, you can already see that I had 10 to the 5th here. But how did I get that? Because I'm going to do 2 minus negative 3. And when you do 2 minus negative 3, subtraction is the same as adding the opposite. That's why this becomes 2 to the positive 5th power. So a little review there on whenever you subtract by a negative, it's the same as adding a positive. Now, is 0.7 already in scientific notation? No, it is not, because the first number needs to be a number between 1 and 10. 0.7 is not between 1 and 10. So we're going to have to make that become 7.0 or just 7, and that would be times 10 to the negative first. 10 to the negative first times 10 to the fifth is going to give you 10 to the fourth. And now you have it in scientific notation. Problem number 12. Again, 1.224 divided by 6 is going to give you 0.204. 10 to the negative fourth divided by 10 to the sixth, you would do negative 4 minus 6. Now, once again, how good are you at subtracting with negatives involved? When you have negative 4 and you subtract away the 6, again, subtraction is the same as adding, the opposite, and so this is why it's going to give you an exponent of negative 10. Is 0.204 in scientific notation? No, it is not, because the first part has to be a number between 1 and 10. So move that decimal point to be after the 2, and that makes it 2.04 times 10 to the negative first. And then, when you have 10 to the negative first times 10 to the negative 10th, add the exponents, and when you have a negative plus a negative, you will actually add in your head, and so that's going to give you 2.04 times 10 to the negative 11th. All right, we're going to finish up these guided notes with two word problems, number 13 and number 14. Read it to yourself, figure out if this is going to be a multiplication or a division problem. Show the work. I have room over on the right-hand side of the paper. And then once you're done, you can go ahead and hit play on the video to see how you did. So hit pause on the video, do number 13 and number 14, and then when you're done, hit play to see how you did. All right, I hope you've already done number 13 and number 14. Number 13 says that in 2010, the population in China was about 1.3 times 10 to the ninth. According to census data, the population in the United States of America was 308,745,538. Now, key word, about. About means some kind of rounding should be involved. About how many times greater was the population of China than the population of the United States in 2010. If I want to find how many times greater something was than something else, then this is going to be set up as a division problem with the bigger population in the numerator. Now, before I set up the division problem, since it said about, we are going to round the 308 million to 300 million, which is 3 times 10 to the 8th. And I would recommend doing that since you are going to set this up as a division problem. Now, how did I know to put the 1.3 times 10 to the 9th on top? Because China's population is the bigger population. And if I want to find out how many times greater the population of China was than the population of the United States, then I have to start with the population of China. All right, 1.3 divided by 3 would give you, it's roughly 0.4. Now, it's not exactly 0.4, and I would probably use my calculator for this for sure. 1.3 divided by 3 was 0.433333333. But since, again, the direction said about how many times greater, then rounding this is actually quite appropriate. 10 to the 9th times 10 to the, or sorry, not times, 10 to the 9th divided by 10 to the 8th, you would subtract the exponents, and that would give you 10 to the 1st. Now, did the directions say we had to have this answer in scientific notation? No, it did not. So we're going to put this actually in standard form. If you take 0.4 and you multiply it times 10 to the 1st power, that's going to take the decimal point and move it one place to the right. And so that's going to give you an answer of 4. So the answer is about 4 times greater the population of China was than the population of the United States from the year of 2010. All right, finally, problem number 14. Scientists estimate that there are over 3.5 times 10 to the 6 ants per acre in the Amazon rainforest. That is a lot of ants. If the Amazon rainforest covers approximately 1 billion acres, find the total number of ants. write your answer in scientific notation. Now, this did not say the word about, so we're not going to do any rounding on this problem, unlike what we did with number 13. So what do I have to do? Is this a division problem again, like number 13? Well, I know that it's over 3.5 times 10 to the 6 ants per acre. And what do they give me? The number of acres. So this is the situation where you are going to take per acre as times the number of acres. So set this up as a multiplication problem. Now, it's up to you. I'm actually kind of going against what I said on the first page. I'm actually doing method 1, where I take the 1 billion and write it in scientific notation. 1 billion would be a 1 followed by 9 zeros, so that is 1 times 10 to the 9th. Now, do I really even need the 1? No, I don't really. I could have just said that 1 billion was just 10 to the 9th. And then 10 to the 9th times 10 to the 6th, you would add the exponents. Of course, 3.5 times 1 is 3.5. So again, I don't really know why I even bothered putting the 1. To be quite honest with you, it really wasn't worth my time. But 10 to the 6th times 10 to the 9th is 10 to the 15th. And cool, this answer is already in scientific notation for us because 3.5 is a number between 1 and 10. So there you go. That's the answer to this problem. And that concludes the guided notes on multiplying and dividing with scientific notation. Thank you for watching. We'll see you next time.